Welcome to Module 201A, Part 4. This is going to be on our trigonometric functions of a triangle. In Objective 6, we looked at Pythagorean theorem. Now the point of Pythagorean theorem is to be able to solve a side of the triangle when you already have two other known sides. But what if you don't have two sides? What if you have one side and one angle? Or what if you want to solve for an angle and not a side? This is where trigonometry comes in. So trigonometry is looking at the ratio and the respective coordinates of the angles and the sides all together. The first thing we need to know is how is the angles and sides identified on a triangle. When we looked at Pythagorean theorem, we discussed the sides already. The base was a lowercase b, the vertical was a lowercase a, and the hypotenuse, the longest side, was a lowercase c. Whenever we look at the sides, we always want to use the lowercase letters to represent the different sides. And that is because we use uppercase letters in order to represent the angles. Now, one thing we should understand is that the angles are always going to be opposite the related sides. So angle A is opposite side A, angle B is opposite side B, and angle C, which is our right angle, is always opposite side C, or our hypotenuse. When it comes to trigonometry, we have three different trigonomic functions to use. The sine, the cosine, and the tangent. And each one of them is a relationship between two sides of the triangle and the angle that it represents. In each one, we're going to represent the angle by the Greek letter theta, which is that circle with a line through it that represents theta. The sine formula is when you want to figure out what the sine of the angle is, you take the opposite side to the angle and divide it by the hypotenuse. For example, when we're trying to figure out the sine of the angle A, we take the opposite, which is side A, divided by the hypotenuse, which is always going to be C. If we wish to find out what the sine of side B is, we would take the opposite of the angle B, which is side B, divided by the hypotenuse. This is important to understand because anytime that you're trying to solve for any particular angle, you have to use the opposite to that angle. There is no one side that's always opposite. It's always in relation to the angle you're trying to solve for. Let's do this example here. We are going to find the sine of angle A, which is the opposite side, so side A, over the hypotenuse, which is our C. Our side A has a value of 10. Our hypotenuse has a value of 22.36. So if you divide 10 by 22.36, you come up with a decimal point. So the sine value of angle A is equal to 0.447. But now the question is, how do I use that as an angle instead? Because I don't care what the sine is. I want to know what the angle is. I want to find out for theta, right? So the opposite of a sine is an inverse sine, or sine to -1, or a sine. So what you want to do on your calculator is use your second function sine, and that will convert that decimal point, that 0.447, into an actual degree that we can use. So if I do an inverse sine 0.447, I get an angle of 26.6 degrees. This is how we use trigonometry to figure out what the angles are, depending on what other information that we have. So if I have two sides and I wish to find the angle, and the side is opposite and the hypotenuse, I can use the sine function in order to solve for that angle. The next trigonomic function we're going to look at is the cosine function. The cosine function is kind of like the brother to the sine function. It works the same, just a little bit differently. Where sine was opposite over hypotenuse, cosine is adjacent over hypotenuse. So if we're going to find out the cosine of angle A, for example, my adjacent side to the angle of A is actually side B. So adjacent meaning beside. And then of course we have our hypotenuse. So to figure out the cosine of angle A, it is going to be divided by C. If I wish to figure out the cosine of angle B, the adjacent side to angle B is side A. So it had to have side A divided by side C, being the adjacent side divided by the hypotenuse. To do an example, we have the same triangle we had before. We can figure out what the cosine of side A is. Cosine is the adjacent side, which is side B, divided by the hypotenuse. So we have 20 divided by 22.36, which will again give me a decimal point number. So the cosine of angle A equals 0.894. Just like I did with the sine, in order to take this decimal point and convert it into an angle, I want to do an inverse cosine. So second function cos on your calculator, for example, and I can take this 0.849 to the inverse cosine of that, so it takes it from the cosine value to an angle value, and I find once again my angle is 26.6 degrees. So with the information I have on this triangle, I can use my sine value to be opposite over hypotenuse, or I can use my cosine values to be adjacent over hypotenuse, and both of them gave me the exact same angle. The third and final trigonometric function that we're going to talk about is the tan function. The tan function is the only one that does not use the hypotenuse. Instead, tan uses the opposite side over the adjacent side. So if I were to figure out the tan of angle A, I'd use side A over side B. If I was going to find out the tan of angle B, it would be side B being the opposite over side A being the adjacent. Keep in mind that what is opposite and what is adjacent is all relative to the angle that you're talking about. Make sure you don't confuse that. Back to our same triangle that we had before. If we're going to do the tan of angle A, which is going to be the opposite side over the adjacent side, we're going to have side A at 10 over side B at 20, gives us a tan of 0.5. So tan of the angle A is 0.5. Just as we did with the other two functions, we're going to do an inverse tan. So second function tan on your calculator. Inverse tan 0.5 returns to us a value of 26.6 degrees again. So you can see how these are all related and how we can use any one of these formulas to solve for any one of our angles. All we need to make sure that we use is the proper formula, and we use the proper sides within that formula. Make sure that the opposite side is always the side that's opposite the angle that you're trying to solve for. The adjacent side is the side that's always beside the angle that you're trying to solve for. The hypotenuse is always the longest side. Here are our three trigonometric functions all put together. We can use the acronyms SO, CA, TOA to represent each one of the formulas. SO, which would be for sine, is opposite over hypotenuse. CA, which is cosine, equals adjacent over hypotenuse. And TOA would be tan equals opposite over adjacent. Make sure you know what each one of the sides are and how they are represented, as well as how everything else inside the triangle is represented, such as what theta means and what the function of theta is. Don't be surprised if the function of theta turns out to be decimal, or in the form of tan, it could even be a whole number. Anytime that we want to change from a function to a decimal, we use the negative function or the second function on a calculator in order to change it from a sine or cosine to tangent into an angle. That is the end of part 4. The hardest part about trigonometry is remembering the formulas and when to use them. Make sure you review SO, CA, TOA and understand how those acronyms can help you remember the formulas. Go through your module and then go to Blackboard and do the worksheet and the knowledge check. Once you've done that, continue on to part 5.